Our next speaker is Faizan Javed, the Senior Manager of Data Science at Home Depot, where he leads the data science efforts for HomeDepot.com e-commerce product search. Previously, he was Manager of Data Science at CareerBuilder, where he built and led applied machine learning and information retrieval teams across a wide range of data science initiatives. Before that, he held several technology roles in many diverse industries such as finance, advertising, and healthcare. He's also published and presented at leading conferences such as ACM KDD and AAAI, including a Best Deployed Application Award. He was the founder and co-organizer of the Data Science for Human Capital Management series of workshops. He has earned his Master's in Science in Bioinformatics, Certificate in Technology Entrepreneurship, and PhD in Computer Science, all from the University of Alabama in Birmingham. Please welcome Faizan.
Thanks everyone for I just realized that that's a pretty long bio. But all right, so I think I want to talk today. So as I mentioned, right, so my name is Faizan Javed. I'm going to talk today about the topic of query rewrite techniques for search. So this is going to be a high-level overview. I'll not do a deep dive, but hopefully by the end of it, you'll all understand what those terms mean if you don't. So going back, so just a quick recap. So we just had the bio. So I'm currently a senior manager of search science at HomeDepot.com. So basically my team actually controls and contributes to the HomeDepot.com search experience. So if you go to HomeDepot.com and you search, that's where my team currently operates. So I'm going to give a little bit of overview of that as well. So I've been, previously I was at CareerBuilder for 5 years, doing a lot of stuff in data science. And I have a background in both engineering and data science and software engineering. So I've had publications in a wide range of areas. So if you have any interest, I'll be glad to talk to you about that as well. And of course, I also co-organized a couple of workshops at IEEE ICDM and ECML-PKDD last couple of years. We'll also have a few new workshops in e-commerce coming up starting next year. And of course, as my academia credentials show, I've been in this area for a while in Birmingham, Atlanta area. So I'm a big fan of Coke Zero, but I still haven't gotten used to sweet tea. All right, so let's start with, so I want to give some basic definitions, right? So search and information retrieval, that's the top level. Those are the two top level brackets that this talk will actually focus on. So I have this definition of information retrieval by Gerard Salton, who's known as the founder of information retrieval. Basically, this information retrieval is concerned with the structure, organization, storage, and searching of information, right? So you have a set of information, you store it, organize it, structure it, and then how do you retrieve it? So at a top level, that's what we mean by information retrieval. And search engines, so this definition is by Bruce Croft and team. Basically, it's a practical application of information retrieval. So at a high level, we are trying to organize information, structure it, and then provide a mechanism to search it, right? Straightforward enough? Yeah. So that's the core definition of these two. All right, so moving on from this to search engines. So search engines, we all have interactions with search engines, right? We search for information using any of the common web search engines like Google or Bing. And I think for a vast majority of us, we also search using Amazon, Home Depot, and other places, right? Those are what we call as e-commerce search engines. So basically, those are, I think, for a vast majority of the population, the way that we interact with search. And of course, there's a slight difference between these two. I'll just highlight that when you're on an e-commerce search engine, your goal is to find what you need, buy it, and get out, right? While if you're on Google or Bing, you might be looking for information. And there are, of course, other aspects as well. So is there anyone here who spends a lot of time on Amazon or Home Depot or e-commerce engine just browsing and browsing? No, right? No. Oh, you. Oh, we have one person. Okay. Because usually, for e-commerce, it's like, hey, I want something, I want to need, and I go through and I find it, and hopefully the search engine is able to find that product or information for you really fast, and then you're out. You purchase and out, right? So, all right, so this is like a whole different talk, so I think maybe I'll schedule another talk on the difference between the two sites, but at a high level, hopefully you understand what the difference between the behavior of how you interact with these two different engines. All right, so let's move ahead. So what's the journey of a search query? So this will give you an overview of what actually goes on behind the scenes, right? So when you type in a search query, we have these three, what I call the building blocks or the engines behind the search. So the first thing, as you see, right, we first have to understand what does that query mean, right? That's the way that people, the engine will be able to interpret what you're trying to do. The second thing is like you need to have the right content, right? If you don't have the content, either in the form of documents or knowledge bases or knowledge graphs, you cannot answer. It won't matter how good the engine is able to interpret the query. You don't have the knowledge base to answer the questions. So that's the second part. The third part is what we call ranking, right? So after you understand the query, you hopefully have the right knowledge to answer the query. The third part is, hey, we have to show the right results, right? Because that's also an equally important part. That's where you have all the ranking and relevancy algorithms come into place. So those three parts are the core engines or of any search engine, right? The final part is like what we call search experience. So once you have the engine up and running, which is able to function properly, you have to have the right user experience, right? So when you go to any website, like how are you able to browse? How are things presented to you? How can you filter? How can you do all those things? So that's what we actually call a search experience. But of course, if you don't have the engine working properly, it doesn't matter what the experience is. You will never get the right answer. So that's at a high level. It tells you an overview of what a search engine actually looks like, the core components at a high level. Of course, each of these are extremely in-depth. We can have a great in-depth talk just on this one component, but this is just to give you a context, right, to help you better understand what we are going to talk about next. So for this talk, we're going to focus on question understanding, or in slightly more technical terms, query understanding. How do we understand the queries, right, that the users or the customers type in? What goes on behind the scenes, and what are some of the techniques that can help us do that? So we'll zoom in on that. So a query understanding. So the formal and informal definition of this is we are trying to recognize the meaning of customer queries. So basically, optimize performance, right? So the term here, optimize performance, means that we are trying to shift the burden from the customer or the user to the engine itself. The customer should not have to go in and type more and more descriptive queries, because that takes more time and effort on their end. Can we have a really efficient, intelligent search engine that can understand the queries, right, and make the job of the customer or the user really easy? And that has multiple benefits. So if you're Google or Bing, it helps you actually present information to the users, and you eventually wind up clicking on ads. If you're Home Depot or Amazon, if you're able to recognize the queries fast and present the information, hey, they will hopefully buy stuff from us, right? So that increases our sales. So that's where this part comes in really, really. So here I have an example, right? So if you see, that's a query from Home Depot. So for query understanding, we need to understand what are the core entities that we care about. So at Home Depot, we care about the product type, we care about color, we care about brand, and other attributes. So if a user types in those queries, we're able to understand and successfully those different entities that helps us retrieve the right results. Make sense? So that's one part of it. The other part of the equation is what we call intent. Okay, the user is coming to an e-commerce or a search website. What is their intent? So even if you take the example of e-commerce websites, the intent is always not to shop. They may actually be trying to find information, right? So here we have a Home Depot example where we see queries like how to patch hole in wall. So the ideal thing to show would be like, hey, we have a lot of content from Edgy TV and other places, right, and other big players. So we should not be showing stuff like, hey, here's what you can do with the wall. we should be showing articles. And the same thing applies to Google or Bing. Sometimes you might be going to Google to find travel fairs. So they're able to detect the intent, hey, this person is probably planning for a flight, so we should show the written materials for that, right? So those are the two big parts. Can we parse the entities from the queries to understand what are they looking for? And also, hey, what's the intent? Are they here for shopping? Are they here for finding information on something? Or are they here for buying some stuff? Are they here for travel? All the stuff. So that's what we mean by query understanding. And the better job we do at this, the easier things become for users, and the better it gets for us as service providers, right? All right. So I mentioned this term called query rewriting, right? So obviously, if you understand that query, it means that we are trying to rewrite the queries that the users actually write. So why are we doing this, or why do we need to do this? So sometimes we see queries called as known as low-performing queries. So these are queries that actually don't return any results, or they may return results which are actually underperforming, right? Based on some metrics. So we have defined metrics that, hey, here's a query that comes in, and it's not returning the right results. And these are the queries, not are they only low-performing, they're also high-frequency. So if they were low-frequency, we would not care about them, right? So they're high-frequency queries that you're seeing the customer put in time and time again, but we're also not getting the right results. So that's why we need to tackle these, because our customers are trying to ask for something, but we're not giving them the right answer. And usually, why does this happen? This happens because of this thing called vocabulary mismatch. So there's a mismatch in terms of what our customers are asking for using certain terms and what terms are used in the knowledge base. So there's a mismatch going on. So here we have some examples from Home Depot. I became a handy guy after I joined Home Depot. So I actually grew up in skyscrapers in the Middle East. So it was the first time I came to the US, and I became a homeowner like 7 years ago. And that's when I started getting into all this stuff. So to me, it was like I would be a user who would be like trying to specify stuff like, how do you cut grass? And then, so that's the stuff. And this is a real example. Like my wife, who's from here, that's what she makes fun of, that I'm not a really handy guy. So Home Depot is like giving me some really great education. So we have the example of things like elbow and sheetrock mud and clog remover and faucet connector, right? So those are the customer queries that we are seeing, and our knowledge base actually has them in this form of drain auger and so forth, right? So this is the vocabulary mismatch. It's a very well-known problem, even in common search. So, all right, so we understand why are we trying to do this, right? So it boils down to trying to increase precision and increase recall. So that's the goal from a data science perspective, that you want to increase the precision and or recall. And of course, if you're trying to increase precision and recall at the same time, you have to have the right balance to that, right? So that's what the use case here is. We want to rewrite the queries to optimize performance and hopefully increase precision or recall according to the business problem or your use case, right? All right, so what are the techniques for doing this, right? So we will actually go over at a high level across these 4 techniques. So we'll go over query scoping and query segmentation if you want to increase precision. And we'll go over query expansion and query relaxation if you want to increase recall. And those are the well-established techniques. And of course, each of them have a lot of different detailed implementation, but hopefully I'll give you some examples that can help you understand how they operate, right? All right, so if you want to focus on increasing precision, so what exactly is going on here? We want to reduce irrelevant results, right? Or decrease noise. So what's happening is that someone is typing in a query, and we're getting a lot of noise in the results that don't make sense. So let's take the example of what happens when you apply the technique of query segmentation. So we are trying to partition the query into units that make sense, that go well together, the semantic segments, right? So take the example of Atlanta Home Depot stores. it's easy to understand if you're a human, right? So, but if we partition or segment the query as Atlanta, home, depot, and stores, most likely you will not get the right results. So we want to actually have Home Depot as a query segment that goes together, right? That's the right partitioning technique. So that's the high-level concept here. A query segmentation, partition the units of the query that go together, and that makes sense. And how can we do this? So this is another area of research. So you can actually have, if you are operating in a certain domain, right? So Home Depot operates in the home improvement domain. So we have a dictionary of phrases that we know will go well together, or do go together, or make sense from our domain perspective. So you can actually leverage those dictionaries. You can use many of the currently in vogue techniques for word embeddings. So if you're familiar with word embeddings, there are a lot of techniques like word-to-vec, glove, bird. You can apply these. So these techniques actually find co-occurrences of phrases in a corpus of data. So you can apply these techniques. And you can also apply some like machine learning techniques for binary classification. You can apply it on a token, and that trained classifier can make a decision on whether that token should continue or whether it should end. And of course, it all depends on the quality of data that you have, right? If you have a lot of great quality of data, labeled data, then it's great. If not, then you'll struggle trying to apply many of these techniques. So that's query segmentation to increase precision. Next, we have query scoping. So this is the named entity recognition problem. So we want to map those query segments to entities. So if you see the example here, we should be able to recognize, hey, that's the brand, rug is the prototype, and 7x9 is the dimension attribute. So applying named entity recognition techniques, which is an NLP technique, most of the existing implementations and the cutting-edge implementations, they use a lot of conditional random fields and LSTMs. So LSTMs are like deep learning models, right? So those are the current state-of-the-art modeling techniques to perform NER on queries. And once again, whenever we mention deep learning, it gets people excited, but there's a lot of stuff that goes on behind it where you have to have a lot of training data, a lot of proper labels to make this actually work. And deep learning also has some instances where you have to make sure that, in our case and in the case of applying NER to search, we have a lot of search performance requirements, right? It has to run in near real time, while deep learning is mostly quite computationally intensive. So that's query scoping, and then we have this technique called query classification. So this is like a simpler version of query scoping. We are actually operating at the query level. So if I type in a query, it's actually going to restrict the results to certain categories, right? So if you take the example here, we have a garage door weather stripping, we will, based on some machine learning models and historical customer behavior data, we can restrict the results that are coming back from the search engine only to door and windows and hardware categories. This way, the search engine is more performant. It does not have to hit all the categories in our knowledge base, right? So we know beforehand that this query will most likely have results in these one or more categories. So that's what we call the query classification approach to restrict the results. All right, so that was taking care of precision. Now, how about recall? So what are we doing with recall, right? So if you happen to have some issues where you want to increase the understanding of your queries, and if you want to increase the set of results, you may have queries that are not returning any results at all, but customers are asking for it. So one common technique for this is query expansion. You can expand the queries by adding phrases and tokens which are similar or related. That's what we call expansion, right? So here, one thing that we have to keep in mind is that if you have some terms that are related, they may not be they may introduce some subtle changes in meaning. So it requires some slight balancing act of how do you exactly expand the query, right? So here's one really basic example from data science, ML developer, right? So you can expand ML to machine learning because that's what is the most likely expansion of the acronym. And then you could also expand developer to engineer, right? that way we are expanding the pool of like how do we search and return the results that might be more relevant and related. So once again, how do we do this? You can have a dictionary of abbreviations. You can apply techniques for pattern matching, synonyms, right? So most likely knowledge bases and knowledge graphs. If you build those using all the embedding techniques that we have, you can define synonyms that, hey, these words are similar or they're synonyms for each other. And this goes back to the problem that we discussed, the vocabulary mismatch problems. There are some terms that people use which have similar meaning but different syntax. So this is what is handled when you're trying to expand the query. All right, next we have the technique for, hey, we are trying to expand the query, can we also remove tokens and relax the query, right? So in this one, if you see the example of black propane grill. So one way to tackle this is that, hey, maybe if we just focus on propane grill instead of black propane. And this is because we see that propane is a more specific term. So this is like we are trying to remove or edit tokens, and that can actually help you tackle this problem of, hey, maybe we can have a smaller term, smaller query that returns us more results. And one common technique that happens here is that people try to remove stop words. So stop words work in most cases, but we have some examples where it does not, right? Like how many of you have heard of the group The Who? So let's say that we are building a search engine for Amazon Music, right? If you apply the technique of removing stop words for The Who, you will probably not get anything, right? So we have a minute subset of use cases where removing stop words doesn't help. And of course, going back to knowledge bases and knowledge graphs, right? So you have semantic relationships. We know that wall heaters are a kind of heater. So we can transform and relax the query by making it less specific, but still in the same space. Hey, we are still looking for heaters, but maybe not wall heaters, and that can probably result in more results being returned for your query. So at a high level, that's what goes on with query relaxation. All right, so now I'll just briefly cover like what exactly has been going on in the industry and the research space in this area, right? So overall, over the past decade or so, things have been moving from trying to apply synonym techniques to natural language processing-based techniques, and now techniques that are being influenced by e-commerce use cases. So I'll just briefly cover some of the papers that we have been researching and also applying to our problems, and that can give you a fuller context now that you have the baseline covered. So going from late 90s to early 2000s, these are the techniques that would mostly fall under what we call rule-based systems. So if you look at the first example here, based on the documents that users have clicked in the past, right? So one approach could be like, hey, you find the clusters of all the similar queries, and then you apply k-means on it. So we have the example of jacuzzi. If we have most products that are bathtubs, then that query will be mapped to walk-in bathtub. Another approach around this time was using WordNet. How many of you know WordNet? I see a few hands. I see hands like Eugene. So basically, finding synonyms for expansion and disambiguation, right? So this is the example of Samsung refrigerator using the WordNet library. And then we have query expansion using hypernym and hypernym extraction. So in this one, this is a combination of using association rules and WordNet concept extraction. So in this case, we know that wheels is a higher level of abstraction for something like cartwheels, right? So all the things that we've discussed as a basic foundation have been applied in these techniques. Moving on to NLP language models. So this is where we actually start talking about embeddings and word vectors, right? So if you look at the first example, there's a difference between having these embeddings from the local space versus the global space. And by that, I mean, like, if you take the example of Home Depot, we want to create these language models based on data from the home improvement domain, not from Google's expansive domain, right? So if you take the example of cutting, the meaning of these two words are quite different if you switch the domains from local to global. In the first one, cut is focused mostly on the tax system, right? Tax, ward, budget, reduction. In the second one, cut has a more general meaning mixed in with the different interpretations. Spend, lower, slash, reduce, right? So the focus here is that, hey, let's create the word embeddings from our local space, and that can help us tackle our problem easier. And a similar approach was also like based on word embeddings and applying that to the relevance model for search. So in this one, once again, if you see the example of recycle can, the terms that are generated are all highly related to recycle can. So if you go back and just recall what we talked about, query expansion, you can expand the term using these terms, right, which are highly related. So these are all techniques that have been using embeddings. And finally, we have our e-commerce use cases. So these are all the use cases coming in from many e-commerce entities and companies like eBay and Amazon and other places. So what's happening right now is that what we're seeing in the space is query expansion and query understanding techniques are being heavily influenced by e-commerce use cases. As e-commerce increases in its global share of the online business, they are having an influence here. So to quickly go over this, in the first approach, you can actually do a replacement of the terms based on some historical data that you have on which you can apply the word vector. So in the example, we see that iPhone watch can be changed to Apple Watch. And in the second one, that's an interesting case where most of the e-commerce properties have taxonomies, right? So if you browse, if you go to homedepot.com or Amazon, you'll see all the items are organized or classified under top-level categories like books, electronics, and so forth. So in this second approach, they're able to actually handle those queries which have low rates of expansion by mapping them to previously sold and listed items which were in some parts of the taxonomy. So using historical data, they're able to infer that what is going to be the most likely place from which. So this is an example of query classification where we are trying to restrict the results to certain categories. And finally, going back to our domain-specific frequency models, here based on your domain, right? So you may have some terms which are highly frequent and reoccurring, so you can actually swap out the interpretation of those terms and reformat the query, right? All right, so this is basically a very fast and high-level overview of a lot of techniques and a lot of works that have been going on in this space, right? So hopefully this was useful. So just to do a quick recap, we do query rewrites to address the low-performing query problem, which is mostly due to the vocabulary mismatch problem, right? There's a difference between what the users are asking for and what exists in the knowledge base. And the two areas of focus, to increase precision, to increase recall, we covered like 6 different techniques for that. And the query rewrite systems have currently evolved from rule-based systems to NLP methods to newer techniques that are being influenced by the e-commerce use cases. And we have a lot of stuff going on at Home Depot. So this is actually the first half of the first part of one of my longer talks. So hopefully next time we can discuss what exactly are the things that they're doing at Home Depot. But if you have any questions or comments, or if you want to get together, you can shoot me an email. And of course, homedepot.com, data science is rapidly expanding. It's in all areas, so we're hiring in search, recommendations, visual AI, exploratory, and Home Depot is actually one of the places in the Southeast where you can actually work on these things on a massive scale. Thank you.